Welcome to part 18 of how to make a coal-fired steam engine boiler plant. And this one is making the exhaust condenser. In model form, it's more of an oil trap than a condenser, and this is not to be confused in any way with a condenser fitted to a full-size steam engine. My condenser oil trap starts with a piece of copper pipe. This is 16 gauge pipe, and it's 4 inches long and has an outside diameter of 2.5 inches. The copper I get from Blackgates Engineering, but the top cap and the base, I got those made up by a friend of mine who's since retired. The first thing I have for you is a top tip. This is a piece of steel that I turned to fit inside the copper tube, and this is to prevent the chuck jaws from crushing the copper. Copper is a very soft metal. This is a 4-jaw self-centering chuck, and it's actually okay without it on this chuck, but when I used to use my 3-jaw chuck to do this job, I did have 1 or 2 disasters. The idea is not to clamp the piece so tight that the copper presses down onto the steel inside it. It's just that if the lathe tool grabs, the copper cannot move very far before it's stopped by the large piece of steel bar that is inside the copper tube. And when using a 4-jaw self-centering chuck, this steel bar inside the tube is free to move up and down slightly. If you use a 3-jaw chuck, this distorts the copper and clamps it tightly. When machining copper, it seems to be a good idea not to run the lathe too fast, and it's a very good idea to use an extremely sharp cutting tool, and I recommend only taking light cuts. This clip has just shown me using my deburring tool on the inside edge of the tube, and now I'm using a file on the outside edge. Usual health and safety rules apply. Always make sure your file has a handle and keep your fingers well clear of any rotating parts. And this clip shows me reversing the tube in the chuck to trim the other end. This is an identical procedure to the one that you've just seen, so if you missed any of the first part, we'll consider this to be part 2. Well, currently my YouTube channel is doing quite well. The sudden increase in views a couple of weeks ago has now settled back down to a trickle. It's strange how it works out like that. I notice a lot of things on the internet work in the same way. The good news is I've finally ordered the parts from Stuart Models. I'm about to make the video series How to Build a Model Steam Engine, and this will be one of the most comprehensive video tutorials you've ever seen. And this series will feature me constructing a Stuart Models Victoria horizontal mill engine, from opening the parcel that the postman brings to running the finished engine in steam. It will be quite a long series and it will be extremely detailed. Watch this space. But for the moment it's back to this job. And what I'm doing is drilling a hole in the side of the tube, and this is for the exhaust inlet. First of all, I'm drilling it with a centre drill, as you can see here, and then I follow it with a tapping size drill for 5/16 by 32, which is 2 imperial drill sizes less than 5/16, and this is a 9/32 drill. But if you want the totally 100% correct tapping size for 5/16 by 32, you could look online or look in the Model Engineer's Handbook. And as a reference point, the Model Engineer's Handbook was not written by the man called Pete who posts videos here on YouTube. Without removing the work from the chuck, I'm threading the hole, that way I know the thread is square, and now I can screw in this little U-nin. To tighten up this U-nin, I'm using my Barco spanner, or should I say Baco spanner. And please watch how I use it. I really am sick of people telling me I should not be using adjustable spanners. These experts really do get on my nerves. But alas, it is all part of life's rich tapestry, and we have to put up with these people. You will notice that as I'm using the Barco spanner, I'm readjusting the jaw position all the time. My finger is always on the wheel, holding the jaw positively against the work, and by using the spanner this way, it is almost impossible to round the edge of whatever you're using the spanner to tighten. And one advantage that can be a disadvantage is the fact that the jaws on an adjustable spanner are much wider than the ones normally found on a small Model Engineering type spanner. I'd just like to say a few words about soldering. This is soft soldering. It's a lead-based alloy. And a health and safety warning, you can of course use lead-free solder. It's probably better for you, but I tend to use this stuff which contains lead. But I try not to eat it, and I always wash my hands after handling it. Some people appear confused. I don't mean that as a general term. What I mean is that some people are confusing soft soldering with silver soldering. What's the definition? I don't know, possibly Google would have a better one, but my definition is soft soldering uses a low melting point alloy and a suitable flux. The flux, of course, is used to clean the metal, and these fluxes are either acid-based or resin-based. Silver soldering, on the other hand, uses a high melting point alloy that contains quite a lot of silver, and the flux is entirely different. It's a white powder that you mix with water. And also, of course, the temperature required for successful silver soldering is much higher than that used for soft soldering. And while I'm on the subject of silver soldering, I received a comment from a chap the other day, and he was an expert and said that I was silver soldering all wrong, and told me that I should be using oxypropane or oxyacetylene to do this. Now just a minute, these videos are designed for beginners. How many beginners do I know who have oxyacetylene facilities in their workshop? I don't, and I'm not a beginner. I did of course reply to him before I blocked him. Another viewer bites the dust. I put an extra feature in this video. While I was telling you about the silver soldering and the soft soldering, I left an image on screen of the part cooling. So not only do we have paint drying on this channel, we have hot parts cooling. What an innovation. So that's one hole drilled. I'll use a paintbrush to remove the swarf and then move across to the other hole. You can clearly see the manufacturing process. This is not just a disc of brass. It has a groove all the way around the outer edge, and the centre marks were spotted to drill the holes. I drilled those holes 9/32 of an inch, which is the tapping size I use for 5/16 by 32. I could have tapped these holes while the part was still in the drilling machine, but I prefer to do it this way. This is a tap guide that I made, and I actually did a video about making tap guides if you want to watch it. These tap guides ensure that the tap enters the hole at a perfect 90 degrees to the work. These tap guides are very easy to make. I've made several in different sizes. If you're new to this hobby and you've only just bought your first lathe, these are great things to make for a bit of practice, because there's plenty of plane turning, and there's plenty of drilling, and there's also a little bit of knurling. And if any beginners have not bought a knurling tool, it's time to go and buy one now. A knurling tool, of course, is not an essential piece of workshop equipment, but it's a very useful thing to have. It gives a professional finish to your work, especially when I put it in focus, that's better, and it makes small parts much easier to handle. I would normally use a tap wrench for this job, but this is quicker, and it's a ratchet, so I just turn it round to undo the tap. I've been unable to show the process by which the top cap and the base are made. It was done on a pantograph at an engraver's. Unfortunately he retired, so there won't be any more of them, but it's an easy part to make in the workshop. Now that I've tapped both of the holes in the cap, it's time to solder it to the top of the tube. But before I start, I'm using some Scotch-Brite to clean up the top of the tube, because this was badly tarnished by the heat that was generated when I soldered the base. To make sure that I get a perfect seal on this top cap, I'm using some commercial flux. This is acid flux, and all I'm doing here is just brushing this flux around the edge and into the groove of the top cap. After applying a generous amount of this flux all the way around the cap, I position the cap on the tube, and then I sight it from above to make sure that the two threaded holes in the cap are exactly in line with the base. And then, just as before, I apply some heat with my blowtorch. I'm only applying sufficient heat to melt the solder and make it flow. It's no good soft soldering at a really high temperature, because all that happens is the flux suddenly oxidizes into something that isn't flux and doesn't do its job. I'm using very thin multi-core solder. This is electrical solder, and I touch it on the work very early on in the process, just as a test to see how hot the part is. And when the solder starts to flow, the part is hot enough. I'm not doing this very well because the camera's in the way, and I've got to be really careful that I don't point the blowtorch at the camera, otherwise the video will stop working. Well, that's my excuse anyway. If I get any solder where I don't want it to be, like this piece on the edge of the top cap, it's not a problem, it cleans off very easily. I'll show that in the next episode. So once I've gone all the way around with the blowtorch and fed the solder in, it's time to use a paintbrush. This is the paintbrush that I applied the flux with, but I've dipped it in some water so it's coated in a mixture of diluted flux. And this does several things. It gets rid of the oxidised flux, then I can see where the gaps are, which I fill with more solder, and also, as you can clearly see, the flux is cleaning the metal wherever it's applied. By repeatedly dipping the brush in the water, the flux gets more and more dilute and the joint gets cleaner and cleaner. So after doing this for a while, you get a really professional looking joint. That's it for this episode. Thanks for watching and I hope you found it useful.